Hello, I'm Mohammed Jalou from StratusOn. Welcome to another Battle of the AI Coding Assistants video, which we compare Gemini, Claude, and Moka in an Azure infrastructure scenario. After our last video, we got a lot of great feedback, but we also got a lot of comments that the scenario was not very representative of how DevOps engineers work, specifically in terms of modularization, which is how they maintain their assets in source control and update them over time. So this time we figured we'll up the notch and ask the three AI coding assistants to come up with an Azure deployment that involves nested deployments, one for a Linux VM, another for a Windows 11 VM, a third for a virtual network, and a fourth for a blob storage account, and see how they go about it. We call this category of questions ankle breakers because we noticed how they impact the underlying models for Gemini and Claude in a way that reminded us a lot of how Stephen Curry's crossovers in the NBA impact other players, or specifically their ankles. Just as a side note, the reason we picked Gemini and Claude is because we think they're really good general purpose AI coding assistants. Not so much when it comes to scenarios that require domain-specific knowledge, specifically Azure infrastructure, which is where Moka shines. I guess it's like the saying, when you're a hammer, everything looks like a nail. First, let's take a look at a high-level overview of what we're going to see in this video. As you'll notice, both Gemini and Claude come up with solutions in a reasonable amount of time. However, both of them come up with a broken solution, which makes us wonder whether they're on LSD, whereas Moka takes a little bit longer but comes up with a functioning solution. It's kind of like the race between the tortoise and the hare. So let's start with Gemini. And you will notice that in general, Gemini is pretty fast, incredibly fast, and starts streaming the answer almost immediately, which is incredible. It takes about 20 seconds to come up with a full solution. However, we noticed that it forgot to include 2 of the 4 files it promised to include, so it only includes the Linux and the VNAT deployments, but not the Windows 11 and the blob storage account, which is very disappointing. Next, we'll ask the same question to Claude. Notice that Claude takes a little bit longer. It actually thinks more thoroughly about the question, comes up with a solution after about a minute. It's very clean, the interface, and we can easily copy the whole template, and we can try and test it in the Azure portal. So we can enter the parameters and do the validation to make sure everything is syntactically correct, which seems to be the case. And now we can start the deployment and see if it actually succeeds. And oops, it is broken. It sounds like there is an error and looks like an obsolete or deprecated Windows 11 image. It's pretty old. Now let's ask the same question to Moka and see how it fares. So while Moka thinks about the answer, let's take a look at the question once again so that we can see all parts of it. So we're asking to deploy a Linux VM, a Windows 11 VM in a separate deployment, and a virtual network with a single subnet and a third nested deployment, and a blob storage account in the fourth deployment. And let's take a look real quick at the different parts of Moka's interface. It gives us an idea that it could take between 15 and 2 seconds and 2 minutes to come up with a solution depending on its complexity. Let's take a look at the settings. Notice that we have a quick start question drop down where you can pick any of prepared questions so you can get started quickly. It includes questions in different languages and questions categorized in different Azure resource categories. You can also pick the type of output. Currently, we only support Azure Resource Manager and Bicep. You can also change the language of the documentation to be anything other than English US. And you can choose the performance tier. In the free tier, you can only have the fast performance tier, which uses a little bit less thinking time. After about 3 minutes, our solution is ready. And first we get to see the deployment topology getting rendered. And as it's getting rendered, the documentation is also showing up. And this deployment topology gives us a bird's eye view of what the solution looks like, so we can see easily that all the pieces that we're expecting are all there. And the documentation provides us with the details of the solution. And we'll notice here that the Windows 11 VM image is a more recent one, which is more likely to succeed versus the obsolete deprecated image we saw in Claude's output. And that's the problem with models that use old and stale data and not more recent and fine-tuned models. So let's take a look at the first asset, which is the Azure Resource Manager. We saw the VNet deployment, nested deployment, and the storage nested deployment, and the Linux VM deployment. And finally, we're going to see the Windows 11 deployment. When we look at Bicep, it's a lot cleaner. So you have the main Bicep file, which has references to the modules or the nested deployments. But we also have the clean approach where you can have each module in its own separate file, so you can more easily maintain them in source control and update them over time, which is something that is more DevOps friendly. You can notice each one of those files are available in a separate text box, so you can copy them separately, or you can choose to download everything in the zip file, including the README markdown. You can also get access to the CLI command, so you can easily run the deployment, or you can share a link so that anyone else can get access to your solution. But let's take a look at it in the Azure portal with our one-click test. And let's create a new resource group and fill in the parameters, and let's see if it passes the validation. It seems to go well. So let's initiate the deployment and see if that succeeds, or if we're going to have issues like with Claude. So it's going to take a while, but after 5 minutes, we notice that it seems to have finished successfully. So let's take a look at the resource group, and we see all the resources are there, which is amazing. So in summary, general purpose AI assistants are like a jack of all trades, a master of none. They're not specialized, so they're going to have issues with domain specific areas, and that's why we saw a lot of hallucination, or what we call the LSD effect. And if there's any point in a fast result when it's incomplete and broken and it doesn't work, and that's why with Moka we focus more on taking more time and getting a functioning and deployable solution, so that we don't waste the user's time in this experiment of trying things and then failing and coming back. So give it a try today. Go to StratusOn.ai and enjoy the free tier of Moka. We're confident that you will love it. Thank you so much for your time. Bye-bye.